Today we're going to do log properties, and in order to do that, we're going to go ahead and recall our exponent properties from Algebra 1, since exponentials and logs work together. So we'll start with our first exponential property, the zero property. That tells us that if we have b to the 0 power, it is equal to 1. So any base raised to the 0 power is 1. For example, 2 to the 0 is 1, 3 to the 0 is 1, and 4 to the 0 is 1. The log property that's going to match that is called the zero property of logarithms. And so it is log base b of 1 is equal to 0. So a log with any base that has an argument of 1 is equal to 0. So log base 2 of 1 is equal to 0. Log base 6 of 1 is equal to 0. Anything with an argument of 1 is going to be 0. Our next property is the base raised to the first power. So a base raised to the first power is always going to be whatever the base is. In this case, 2 to the first would be 2, 4 to the first would be 4, 5 to the first would be 5. So whatever the base is what our answer is going to be. That means even a fraction. 1/2 to the first power is 1/2. Its matching logarithmic property is logarithm with the same base and argument. So if we've got a log with a base of b that has an argument of b, it is going to be equal to 1. So log base 2 of 2 is equal to 1. Log base 2 of 3 is, log base 3 of 3 is equal to 1. Log base 9 of 9 is equal to 1. The common log of 10 would be equal to 1, because remember, if it does not have a number written there, it is a base of 10. And so log base 10 of 10 is also 1. All right, now we'll get to the ones that are a little bit more thought that needs to go into them that we're going to use more often. So the product rule of powers tells us that if we have the same base and we're multiplying, we add the exponents. So b to the m times b to the n is equal to b to the m plus n. So we keep that base and we add these exponents. So for example, 3 squared times 3 to the third power, we keep the base and we add these exponents. Write that out for you guys. That's this whole thing. So that would be 3 to the 5th power. Same thing if it was a variable. If we have x squared times x to the 7th power, we keep the base and we add the exponents. So we get x to the 9th power. That property that follows through as a logarithm is the product rule of logs. And so it tells us if we have a log where we are multiplying the arguments, we can change that to a log of m plus the log b of n. So same thing, it's adding, but it's adding the two logs together. So for example, if we have log base 4 of xy, that would be log base 4 of x plus log base 4 of y. So if they're multiplied in the argument, we add the log of each. Notice it's the same log. So log base 4 is log base 4 on both of these. The next one's going to be our quotient rule of powers. And that tells us that when we are dividing two things with the same base, we keep the base and we subtract the exponents. So x to the 4th over x to the 7th. We keep the base and we subtract the exponents. That would give us x to the negative 3rd, which we write 1 over x cubed. All right, for the quotient rule of logarithms, that tells us that if we are dividing two things in the argument, so m over n, we can convert that to subtraction as well. It'd be log base b of m minus log base b of n. If it is dividing in the argument, we change it to subtraction. So for example here, log of x divided by y would be the log of x minus the log of y. And then the last one here is the power to a power rule. And that tells us if we have something that's raised to a power and that entire thing is raised to a power, we multiply these. And so we would get b to the mn. For example there, if we have x to the 4th power raised to the 2nd power, that's a power to a power, so we multiply, we get x to the 8th power. All right, now the power rule of logarithms, we've got log base b of m raised to the n power. So if in the argument it is being raised to the n power, we would multiply that times the log. So our exponent comes out to the front here and we multiply it times the log. So I'll show you an example of that. Log base 4 of x cubed. This would come out to the front to multiply. So we get 3 log base 4 of x. So there's our properties. We're going to use the power rule of logarithms, the quotient rule of logarithms, and the product rule of logarithms quite a bit to expand and condense expressions. So it's really important that you know those and know them well. We are now going to use these log properties to expand and condense an expression that assists us in solving as we move forward. So right here we have log base 4 of 6 times x to the 5th. This is one term right here. By expanding it, we're going to make it more than one term. On the other side there, we said when there are two things being multiplied in the argument, we can change that to addition. So the first property that we would use is the product rule. I expand this to be log base 4 of 6 plus log base 4 of x to the 5th power. I've taken the two things that are being multiplied in the argument and changed it into two logs with an addition sign. Now to expand it completely, we also have to take care of the exponent there. We can now apply the power rule of logarithms to get rid of that power. So we go log base 4 of 6 plus 5 log base 4 of x. Notice that 5 is on the log that had the x because that's the only one that had the exponent. So this one should not have a 5. You would not want to do that 5 first because then it would end up in front of the 6 that does not have an exponent. So this was the product rule, and this was our power rule. All right, for our second one here, now we've got 3 terms in here. We've got 2 being multiplied in the top and then the 1 being divided. So I would do the quotient rule first. And so we get log base 7 of 3y to the 4th minus log base 7 of x cubed. So both of them are log 7s. They're separated by a minus because they were being divided in the argument. Now I need to separate this 3 and the y to the 4th. They're being multiplied, so I'm going to do addition for that. So I get log base 7 of 3 plus log base 7 of y to the 4th minus log base 7 of x cubed. Our last rule to apply now would be our power rule to get rid of those exponents. So our first one does not have an exponent, so it just stays the same. Our second one has the exponent of 4, so that's going to come out up front and be multiplied. And our last one has an exponent of 3. There is our expanded form. All right, we're going to try another one. This one here looks confusing just because it's got the natural log, but remember a natural log is just a log with a base of e. So we would get the natural log of 3 plus the natural log of x plus the natural log of y cubed. So we applied that product rule to separate those three. Now we want to get rid of this power. So we get natural log of 3 plus the natural log of x plus 3 times the natural log of y. That would be our power property there. And that is fully expanded. So you want to keep going until you can't apply a property again to get it any further. For this one here, the first thing I'm going to do is take out that radical. So we learned in the radical unit that we can make that a fractional exponent. So I'm going to change this to be x to the third, y to the fifth, raised to the 1/2 power. That makes it a little bit easier for me to work with. When we have a power to a power, we learned with the exponent properties there that you can multiply. So we get x to the 3/2 and y to the 5/2. That's going to make it easier for us to expand now. Since they're being multiplied, I'm going to go ahead and add the x to the 3/2 and the y to the 5/2 in our argument. Now our last step would be to bring that up front for multiplication. So we get 3/2 times the log of x plus 5/2 times the log of y. That is fully expanded. Now let's talk about condensing. In this case, we're going to do the opposite. We're going to take it from a number of different logs to one single log. We're still applying the same properties. This time we're just taking them from the separated to the together. So in this case, I need them to be exactly the same log, and they're not at this point because there's this 4 in the front. But I know when it's 4 times the log, that can be our exponent. So I apply these properties backwards, basically. The power rule would go first. And so I get log base 2 of x plus log base 2 of y to the 4th power. Now I can apply the one with the addition. We know when they're separated by an addition, that means that the arguments need to multiply. So we get log base 2 of x times y to the 4th. And that would make it a single log. For our second one here, they do both have the same exponent, so you could go ahead and apply the quotient one, but I'm going to go ahead and get these 3's to be the exponent, which is what they are. And so we get log x to the 3rd minus log y to the 3rd. And then we can take it to a single log by dividing, because they're separated by a minus. I know that would be division, so I get x cubed divided by y cubed. All right, we're going to take it to some a little bit longer here. And so I've got log base 3 of x minus log base 3 of y plus log base 3 of m. So I'm going to go ahead and start from the left hand here. So this is going to tell me I'm going to divide the x by the y since they're separated by a minus. So I get log base 3 of x divided by y plus log base 3 of m. I'm going to do it step at a time to make sure that we don't mess anything up. Now they're being separated by a plus, which means I'm going to multiply. And so I keep one log base 3, and I'm going to multiply x over y times m. Now remember, when you're multiplying a fraction times a whole number, this would be over 1. And so it's numerator times numerator, denominator times denominator. So we get x times m over y. All right, for our next one here, I'm going to go take care of what's in the parentheses first. And in this parenthesis, we have a minus here, so that's going to be division. So I keep the natural log, one of those, and I divide the argument. So that would be 3 over x. In this parentheses, I've got the natural log again, and this is a minus, so that would be x over 9. Now I need to get rid of this 3 in order to be able to simplify this addition part in the middle. So I'm going to go ahead and bring that up. That would be the power, and that would be the power to both of those. So I'm going to get the natural log of 3 to the third and x to the third plus the natural log of x over 9. Now we're ready to multiply here because we've got this plus in between. And I can go ahead and simplify this. 3 to the third power is 27, so I'm going to go ahead and make that 27. When we multiply our numerators and then our denominators, so that would be 27x over 9x cubed. We do have it down to a single log now, but I can simplify that, so I want to go ahead and reduce those fractions. 27 over 9 is 3. And then x over x cubed is x squared. And so that would be our final answer there. We've taken it from multiple logs to one log, so we have condensed it. One of the things that we see often on the SATs and some testing is this bottom part here, where we're using these log properties in order to test the log property so that you're not putting it into the calculator. They apply values to it. So log base A of 5 would be P, log base A of 3 would be M, and log base A of 2 is equal to R. So we're going to use that information and what we know about log properties to be able to separate that into something that works. So for 50, if I wanted 5, 3, and 2, those are the only numbers I have, I can think about log base A of 50 as 5 squared, which is 25 times 2. So 5 squared times 2, that's 25 times 2 gives me the 50. Now I can separate it into just the term log base A of 5 and so on so that we can get this simplified. So I get log base A of 5 squared plus log base A of 2. These two are being multiplied, so I separated it into a plus. And then my last step is to get rid of that exponent, so I get 2 log base A of 5 plus log base A of 2. We did that now because this entire thing is P. So that means this entire thing is P, so we get 2 times P plus log base A of 2 is R. So our answer would be 2P plus R. All right, for our second one, we have log base A of 1/3. And so we want to think about which one of these that can work with. The 3 is definitely one that's going to be able to work with. Remember we said a negative exponent causes the reciprocal. So 1/3 is the same thing as 3 to the negative 1 power. By applying that as a power, I can bring that out here. So we get a negative 1 times the log base A of 3. And the log base A of 3 we know is M. So that would be negative M. All right, for our last one here, log base A of 1/27. That would be 3 to the negative 3rd power. Again, that reciprocal, we're using that negative exponent as the reciprocal. So we get negative 3 log base A of 3. Log base A of 3, that entire thing is M. So we get negative 3M. Those are our log properties. You have to be able to use them to expand and condense in order to solve some problems.